All right, so a couple of other nice little facts. We're just going to have a look at some simplifying complex numbers in polar form. First thing, so let's have a look at the little graph in here. If Z1 is equal to cis pi on 4, so that the magnitude is 1, the angle is 45 degrees, so that's about there. Yeah. So what happens, what is negative Z1? Two ways to think about it. Negative Z1 is the same as I squared Z1, so it shifts 180 degrees around, or it's negative cos theta minus I sine theta. So both components are made negative, so it's negative across, negative down, or 180 degrees around the circle. Yeah? So that's negative Z1. The conjugate of Z1 is just cos theta minus I sine theta, which is going to be down here, Z1 bar. And in the same way, if we multiply that Z1 bar by negative 1, it's like rotating at 180 degrees, negative Z1 bar up there. So there's a couple of different ways we can think about the impact the negative sign might have on a point. All right, just remembering that all these represent real numbers. Cis 0, 0, I sine 0, sine of 0 is 0. Okay, so there's just a few nice little facts. When we add or subtract numbers in polar form, we just have to add or subtract them. So we're going to have to expand it, get them into Cartesian form. So we'll end up with 2 cos pi on 3 plus I sine pi on 3 plus 3 outside of cos 2 pi on 3 sine 2 pi on 3 equals 2 outside of cos of pi on 3. They're halves, aren't they? Both positive, so root 3 on 2i. 2 pi on 3, so that's the second quadrant, so that's negative pi on 3, which is negative a half, and that'll be positive root 3 on 2i. Multiply through, so I get 1 plus root 3i minus 3 on 2 plus 3 root 3 on 2i. What's that going to give me? 1 minus 3 on 2 is minus a half. Root 3, so it'll be 2 root 3i plus 2 root 3 on 2 plus 3 root 3 on 2 is going to give me 5 root 3 on 2i. So I guess in short, there's no nice little rule like there is when we look at multiplying and dividing. All right, so if we add or subtract, we've just got to add or subtract them. However, as I intimated, if I multiply or divide, there are a couple of nice little patterns. Yeah, we multiply the magnitudes, we add the angles, and if we divide the magnitudes and subtract the angles. That's the best thing to do, okay? And I guess we can think about what does that really mean? If I've got an R1 here, R1 theta 1 and a R2 theta 2, well then just from a geometric property, if I'm going to multiply the magnitudes together, the product Z1, where we talk about the scaling. Okay, so my magnitude is going to be affected by a factor. So it might increase by a factor of 2 or increase by a factor of 3 or by a half, depending upon the magnitude of the second radius. in terms of an angle, because we're adding the angles together, we're saying that this angle here is just going to rotate a further pi on 2, it doesn't matter, whatever pi on 1 happens to be is added to pi on 2, so it rotates. So multiplying Z1 and Z by the product, rotation of Z1 about the origin in anticlockwise direction through the angle 32. In other words, we're going to rotate that first complex number around by whatever the second angle is, and we increase it by a scale factor of Z2. Similarly, dividing, what are we doing? We're dividing it, so I guess we're multiplying it by 1 on Z2 as a scale factor, and we're rotating it in a clockwise direction because we're subtracting the angle. So we're subtracting in a clockwise direction by whatever the angle theta 2 is. So that's, I guess, the geometric interpretation, to be honest, isn't overly crucial for us. It just gives us a bit of an idea. Physically working it out, okay, I guess the key is 2 by root 3, we multiply the magnitudes and we add the arguments, yeah. The only thing you then have to make sure you do is, so common factor of 12, so 4 pi plus 9 pi, 2 root 3 cis 13 pi on 12. Now 13 pi on 12 is outside our domain. Remember, it's got to be between negative pi and pi. So 13 pi on 12 is all the way around to there, which means I want to make it minus 11 pi on 12. All right. Similar division, we've got 6 on 9, so that's just going to be 2/3 cis pi on 3 minus 2 pi on 5, which is 2/3 cis on 15, 5 pi minus 6 pi, which is minus pi, so it's 2/3 cis minus pi on 15. It's bad 15. It's a bit better. All right, negative pi on 15 is inside the argument domain, so that's fine. We can leave it like that. All right, let's have a go. Here's a really nice question. This is a nice place to pause and get you to work through a couple. All right, hopefully you've had a bit of a look. Polar form U. So we got mod Z is equal to square root of 1 plus 1, which is root 2. The angle tan theta equals 1 on 1, which is pi on 4. We're in the first quadrant, so U will be equal to root 2 cis pi on 4. UV in simplest form is equal to root 2 cis. So obviously we're just going to multiply them. So we're going to multiply the magnitudes, add the angles. I'm going to make them on 12. Pi on 4 is 3 pi. Pi on 6 is 2 pi. So it's 2 root 2 cis pi on 12. And the angle's in the right, so that's good. V in Cartesian form. So it's 2 cis negative pi on 6 plus 2 cis, 2 cos pi on 6 plus 2 sine pi on 6 negative. Cos of negative pi on 6 is going to be positive, so 2 times root 3 on 2 plus sine of negative pi on 6 is negative, 2 times minus a half I, so we get root 3 minus I. Express the product UV in x plus IY form, so we can just multiply 1 plus I times root 3 minus I. What does it give me? Root 3 minus I plus root 3I minus I squared. So it's equal to 1 plus root 3 plus I outside of root 3 minus 1. Hence determine the exact value of sine pi on 12. Interesting. Is there an expression on this page that has sine pi on 12 in it? And if we go up to 2 root 2 cis pi on 12 is equal to 2 root 2 cos pi on 12 plus 2 root 2 sine pi on 12, isn't it? I. So that expression there has to be equivalent to this expression here because they both represent UV. Yeah? Because that was equal to UV from B.
Boys.
So what does that mean? So it means that I, which is root 3 minus 1, so if I compare the I components, is equal to 2 root 2 sine pi on 12. So they're the two I components. So that means that if I just do a division, root 3 minus 1 over 2 root 2 is equal to sine pi on 12. So that last step's a little bit of a trick, but still, the first few parts are really good practice.